So today we're going to look at function behaviors and characteristics. So for function behaviors and characteristics, you watched a video last class or a couple days ago that refreshes your memory on function behaviors, characteristics, basic things. So for these questions, these are a little bit more complex than your notes that you've already done, but we'll make it through. So the first thing I want you to do is just honestly just take a look at the graph that you have here. So just look at it. Do some observations. Look to see what you have. I see some open circles, some closed circles, and it looks like they have 3 different segments that are on this graph, so 3 different areas. When answering the first question says find f of -1. So Andrea, if I'm finding f of -1, what do you think your answer is going to be? Okay, so at -1, you have an open circle at +2. What do open circles usually mean, though? Do those usually mean that you're including an answer or not including an answer? Okay, not including it. It's okay, so look back at the graph. Is there another point that we could probably use at -1? 6, right up here. This is a closed circle, right? It's right on that vertical line where -1 is, so let's use 6 instead of 2. I'm glad you said 2, though. 2 is an open circle, so you can't include that point. So the answer for f of -1 is +6. That's your first answer. You've seen these things before. It's just a matter of combining them. For f of -3, okay, same concept. We need to look at the graph like Andrea did at -3, which is here. And if you look at this whole vertical line where -3 is, there's only one point. And this point down here is open. Does open circles exist? Like if there's not anything filled in? No, if it's open circles, it doesn't exist. So unfortunately for us, for f of 3, we're going to put D and E. That means that it does not exist. So that's your answer. It does not exist. We could put none if you wanted to. If I was to put 0, would that make sense? If I put 0, what that means is at 3, it would literally be on the x-axis. That point would be where your answer is, but we don't have a point at -3. The next one says find f of +3. F of +3, we need to determine if it's positive or negative. So Brooks, look at the graph. At f of 3, is it positive or negative? Positive. +3 is right here. It has this point that's on your graph. So this one is going to be positive. Do the same thing for part D, Brooks. F of -2.5. Is that positive or negative? Say it again. Negative, because -2.5 is here, right? -2.5 would be this dot. So it would be somewhere on this line. So I'm going to put negative. Okay, don't know why I put that line underneath it. This next part says, for what values of x is f of x equal to 0? So if f of x is equal to 0, hopefully you guys remember from Algebra 1, but f of x is the same thing as y. So it's pretty much saying when y is equal to 0, what's the x? Anhad, take a guess. If you look at this graph, when your y value is 0, what do you think the x value is going to be? Can't necessarily just be 0. Say it again. 5.5, that sounds like a guess. That would be my y-intercept, but that's not going to be where y equals 0. Brooks? -2. How'd you get -2? So since it says y equals 0, it's literally talking about on this line, because if I was to graph that line out as a horizontal line, how do you agree that's y equals 0? That's y equals 0. So at y equals 0, like Brooks said, it's going to touch that line right at -2. So if you think about it, this point is -2, 0. That's where my y value is 0. The x is -2. That would be my answer. The next part says, on what interval of f of x, or is f of x less than 0? We've already said this. F of x is the same thing as y. Okay, so this one isn't a trick question. If f of x is less than y, is that going to be above or below the x-axis? Below. It would be all of the space that's below the x-axis. So that's this piece of your graph right down here. Whenever you're writing the interval, you're going to write it along the x-axis. So you're going to start at -3, and it's going to go here to -2. So the interval of this graph that's below 0 on the x-axis is -3 to -2. And on both ends of this -3 here is an open circle, so I'm going to put a parentheses. And this -2, do we want to include 0? No, we only want it less than. So I'm going to put a parentheses around that. That's my answer. The next question asks for your domain and range. So looking at the graph, try to identify what's your domain and what's your range. Just do it before I do. What's the domain and what's the range? Domain goes from left to right. Range goes from bottom to top. And add in a couple of things on your notes. On that yellow line, like how I was talking about with Anhad, that's y equals 0, which means you're really just finding the x-intercept for letter E. I just want to add that piece in. So when you come back later, you know what it is. For part G, it was asking for the domain. Okay, so let me go back to the graph. Domain goes from left to right. So starting on the left-hand side, it's starting right here at -3. Do you guys agree? -3 has an open circle, so I'll keep that in mind. And it's going to go over to the right-hand side. As it goes over, I'm looking at this graph. Okay, this graph is going to the right, and at this open circle, Andrea told us we can't use that point. Instead, we're going to use +6. So whenever you see, especially on this little vertical line that I have at -1, you want to see if there's an open circle, you want to see a closed circle somewhere. If you don't see a closed circle on that vertical line, it's not going to be a continuous domain. So for this question, we're going to keep going. So from -3, it's going to go over to -1. We already talked about this. -1 does have a point. It's 6. So we're going to keep going. The graph is going to continue to go down here. So it's still going to the right-hand side. Over here at +1, is there a value where it'll actually equal something at +1? Where? What's the y value that it'll give me if your x is +1? +1, that guy there. Okay, cool. So it looks like I'm going from -3 all the way over to +1, and along this line, it's going to keep going up. Goes up, 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 and it eventually reaches +4. There are no empty spaces in your domain here. So down here at the bottom for your domain, we're just going to write this out from -3 to 4. Look back up at the graph. Was -3 an open or closed circle? Open. And what about +4? Bracket. If I was to put, so this is for your domain, you don't have to write this out. Let's say instead of an open or closed circle here, it was open. I can't include 1 at that point. So how would you write your domain if you're not including +1? How would you include that, or how would you write out your domain here? Where would it go from? It's going to go from -3 to 1, which is this value here. It's going to go to -3 to 1, and we're going to put parentheses around it. And then we'll go from 1 to 4. That's a comma. 1 to 4. You do not have to write this out. I'm just giving you an example of what it would look like if both of those circles were open. If both of those circles were open, you cannot include that value in your domain. You would have to skip over it. We're going to see something similar to that on the next question. Before I move on, do you understand that empty space in your domain? Because you're going to have questions like this coming up very soon. All right, for the range. The range goes from the bottom of the graph to the top. So Maria, if you're starting at the bottom of the graph, I'm going to -2. You follow the graph that it has and tell me, where is it going from if you're starting at -2? Where's it going to end at? Oh, +3. I love it. If you're going from -2, even though this open circle's here, it's on this line horizontally, which means it would eventually hit this point. So if y is equal to 2, this would be my point. It would keep going up to 3. And then if you actually look, there is a huge open space between 3 and 4. That big square rectangle that I just made, that's a huge open space. So down here for your range, I'm going to go from -2 to 3. And then where's it going to go from there, Maria? From +4 to 6. So I'm going to have to put a union in there. So we're going to union 4 to 6. All you need to do now is put the parentheses in brackets. So at -2, that's a parentheses. At 3, up here where that dot is, that's a bracket. 4 is another parentheses. 6 is another bracket. This would be your range. If you literally have an open circle, which means you're not including it, or like we have here, if you have this big open space, you don't need to include it in your domain or your range. Good job, Maria. All right, last couple things. For what values of x is f of x discontinuous? Discontinuous means that you're really seeing the graph kind of jump from one point to the next. So it kind of jumps from one point to the next. So you always want to look at the x's along the x-axis. So for what x values is the function going to be jumping? Where is it going to go from one point to the next? Well, if we're starting with the graph, it starts at -3. Okay, well, it has an open circle. It's not jumping anywhere. At -1, though, that's a clear example of a jump. At -1, it had an open circle at 2, but the answer was technically up here at 6. So one of the discontinuities is at -1. Where's the other one? Is it +1 or 6? +1. Because at +1, there's an open circle at 4, but the answer is down here at 1. So when that graph jumps on the x-axis from one point to the next, that's where your discontinuity is. So for what values of x? X is going to equal -1 and +1. X-intercept and y-intercept. If I was to look at the graph, Desiree, what's your x-intercept? -2, 0. So I'm going to write that both ways, as a coordinate and as x equals -2. And what's your y-intercept, Desiree? Give me the approximate. What do you think it is? 5.5. I would say about 5.5. So 0, 5.5. If I give you something with decimals, like on a test or quiz, I'll give you more than likely multiple choice. If it's free response, ask me just to make sure. Okay, for the next part, for L, Desiree, I'm already with you. I'm going to stick with you for one last question. It says, how many times does the line y equals -1 intersect your graph? So you and me just talking, y equals -1. What type of line is that? Is that horizontal or vertical? Horizontal. So on this graph in green, I'm going to graph y equals -1, which is going to be down here. Desiree, how many times does that green line intersect your function of x? Once, right here. Just one big time, right there. So down here, all I need to do is write out once, one time. Same thing for x equals 2. If it asks how many times does x equals 2 intersect your graph, okay, I'm going to look at the graph. I'm going to graph this in orange this time. X equals 2 is a vertical line. So vertical would be straight up and down. At x equals 2, it looks like we're only going to hit that graph one more time, that function of x, one time. So down here, just going to add in once. Nicholas, for what values of x does f of x equal 3? So for what values of x does f of x or y equal 3? +4? If I look up here, 3 is this guy. That's y equals 3. That means that my x value, yes, is +4. So when your y value is 3, which is what Nicholas just told us, the point that it's going to touch at for x is +4. That's exactly it. So down here, x will equal 4 once I find it. Right here, x equals 4. Do the same thing for the other one, Nicholas, for O. What are the x value, or what are the values of x if f of x, which is y, equals -2? Does it have an x value? Why not? What's wrong with it? Because it's an open circle. So I would love to say that it's -3, but I can't put that. So instead, we're just going to put none or it does not exist, because that open circle is not going to have any value. So we're going to put D and E, or none. It doesn't exist. For your absolute global maximum value for your function of x, your absolute global maximum value has to be an actual point. It needs to be some point on your graph. So for the global maximum, you're looking at the entire function of x. So this whole graph here. What is the highest point on that entire graph? What's the highest point? 6. That's the highest point. That's literally what I'm looking for. So this would be your global maximum. So up here, or down here at the bottom, I'm going to put for my global maximum just 6. That's all it is. Anytime you're doing the global maximum or minimum, you're always going to write it as your y value. So technically, you'll sometimes see me put y equals 6. It's because I'm reminding you you're only needing to put your y value. Sometimes, especially if I ask you to, I might put what is the x value. for your absolute global or global maximum, the x value is -1 because that's along the x-axis at -1. Or if I ask you to write the coordinate, you would just give me -1, 6. Either of those should be acceptable, but if I write it just like this, I only want to see the 6. That's the only thing I need. These are just extra in case I ask for it. The last question looks disgusting because it asks what interval is f of x increasing, but it's not that difficult. Look at the graph. Is it increasing? Yes or no? Are there portions of this graph that are increasing? Yes. Tristan, what intervals is it increasing from? Give me the values on the x-axis. Where is it starting? Where is it ending? Okay, so this whole graph is increasing?
No, not all of them.
Okay, so only give me the parts that are increasing. From what two values to what two values? Perfect.
1.
That's it. Just those two intervals, from -3 to -1, and then from 1 to 4. Whenever you're writing your increasing intervals, guys, please pay attention. You're going to go from -1, or not -1, excuse me, -3 to -1, and then from 1 to 4. I know you're looking at the way I wrote it saying, wait, Miss Tapia, 4 is a closed circle. I know that. But whenever you're writing your increasing or decreasing intervals, put parentheses. So whenever you're writing your increasing or decreasing intervals, only use parentheses. For domain and range, you can use brackets. But for increasing and decreasing intervals, I want you to use parentheses. All right, so that's pretty much it. Let's look at the next page. So example 2. And I'm going to give you guys like a 3-minute head start. Try to do as many of the questions as you can. Letters A through D on here, letters A through D, you don't know what to do. But for letters E through J, you can at least give me something. Quick question, what's a root? What's a root? Oh, don't make me kick you back to algebra 1. What's a root? Say it again? Not quite. Think of a quadratic function. If I asked you to find the roots for this graph, how many roots would this have? 2. What are the 2 things? Where are they? Not the vertex. You're just guessing. The word roots. There were 3 words you should have learned for Algebra 1. I know it was a couple years ago. Catherine. Where it intersects with the x-axis. Thank you, Catherine. Roots. Write this down now because y'all have clearly forgotten it. Roots are the same thing as your x-intercepts. These terminologies or these words are coming back, guys, so please don't forget it. All right, I'm going to give you guys 3 minutes. Go. Get this done. Work with the person next to you if you need it. All right, let's see what stuff we got. So for E through J, we can definitely do those first because those are what you've already seen. So for E, if I'm asking for the interval where it's increasing, bless you. Catherine, what's the interval that's increasing on this graph? From where to where? You said to infinity? Yep, that's what I got too. So we're going from, for increasing, guys, it's literally where the graph is going up. Don't overthink it. If the graph is going up, it's starting here at -2.9. Can we all agree that this is going up? Okay, good. It gets to 0.3 and it starts to go down. And then at 2.6, it's going to start going up again and it's going to keep going forever. So for increasing, it's going to go from here and here. These are the two intervals that are increasing. So obviously these two that aren't increasing, these are probably going to be decreasing. It's going down here to get to this lowest point, and then it's going to go down here as well to get to that lowest point. So for your decreasing interval, it's going to go from negative infinity, which is this arrow over here, from negative infinity, down to negative 2.9, and then it's going to go from 0.3 to 2.6. Those are your intervals. If you don't understand what I just wrote, guys, please tell me. All right, for the next part, on what interval is f of x less than 0? So, Alex, what's the interval where f of x is less than 0? Between what numbers? Not quite. Think back to the last page. On had helped us with that one before, or kind of similar to it. If f of x is less than 0, that means that all of the y values, so that's what it technically means, all of the y values are less than 0. If all of the y values are less than 0, is it going to be on the x-axis, above it, or below it? Below. So you want all of the space that is below the x-axis. So look at the graph. On the x-axis, what points are below the x-axis, between where and where? No, look at the graph. All of this stuff above we can't touch. So looking at this graph on the x-axis, this point starts over here at what? What's that first point? Negative 4. Thank you, Alex. And then where is it going to? Not negative 3. You're going too far. It's going from negative 4. It's going over here. This is all below the x-axis, right? Tell me where I'm start going above. There we go, negative 1. So negative 4 to negative 1, write that down first. And then the other part on the other side below the x-axis is from 2 to 3. So make sure you make that note. The only intervals below the x-axis are from negative 4 to negative 1, and then from 2 to 3. Why am I not putting brackets again? Do I want it to equal 0? No, I just want it less. X-intercepts. How many x-intercepts are here? We have 4. So your x-intercept should have been x equals negative 4, negative 1, 2, and 3. Those are your x-intercepts. Okay, for the global minimum and maximum. Okay, so for the global minimum and maximum, you want to look at the entire graph that you're given. So all of that. What is the global, what was the first one? Minimum. Negative what? Negative 12, yes. Negative 12.1, technically. That's the coordinate that we have. So down here, I'm going to put, for my global minimum, negative 12.1. That's the y value. If I asked you for the x, of course, you would tell me x equals negative 2.9. And if I asked you for the coordinate, you would tell me negative 2.9, negative 12.1. On tests and quizzes, though, guys, just give me that negative 12.1. Global maximum, be careful. Is there a global maximum? Is there a highest point on this entire graph? Where is it going to? Infinity. Even though I would love to put infinity there, that's not the highest point. The point needs to be an actual coordinate like we saw down here with our minimum. So unfortunately for us, we're just going to put for our global maximum, none. There isn't one. The only time you can have a global maximum is if it's an actual point, like we saw with that global minimum. The last thing that I'm going to look at is letters A through D. On letters A through D, it's kind of like you're looking in a picture frame. So it's kind of like you took this picture, oh, that's so cute, my friends are in it, and you kind of like crop out the people you don't like. Only thing you want to look at is what's inside of this box. It's the inside of this little picture frame. So for the local minimum and maximum, sometimes there will be 1, sometimes there will be 2, sometimes there will be more than 2. On this graph, which one is the maximum? Give me the point. 0.3, 5.1. This is my local maximum. When you look at your local maximum, you want to have points below it on the left and the right. That's how you know you have a local maximum. When you look on the left and the right and you have other points below it. That's what you want to make sure. What about your local minimum? What's your local minimum going to be? Is there more than 1 or just 2? There's technically 2. Sometimes your global maximum can be, or minimum, can be included with your local maximum and mins. So down here, you're going to have 2. This is 1. This is the other. These are your local minimums. So for your local minimum, you should have points that are higher than both of these. So in this case, there's a point higher here and it goes towards infinity. Same thing on this side. There's a point to the left and it goes towards infinity. So for these, I'm just going to write out my local maximum. It specifically says here for the x. So the x for the local maximum is 0.3. What are the local maxima? That's just the y value. It's really just asking for the y. So your y value, which is 5.1. You don't need to put the y equals, but I did. What are the x values for your local minima? So there's two of them. X should equal 2.6 and negative 2.9. And then for your local minima, x is going to equal, or not x, excuse me. It should just be y would be equal negative 12.1 and negative 1.6. And you can put y equals for both, but I'm just being a little lazy. Bless you. For the rest of these, I'm not going to do the rest of them with you. Question 3 is more than likely going to be on your homework, the exact same question. All I need you guys to do is write your answers on this paper and then, of course, write them on your formative if you have that. Before we move on, this last question here for example 4, that's just extra practice if you need it. And I would definitely put at the very end of this 2 arrows to show that it's going towards infinity. So add really quick these 2 arrows. Are there any last questions? Yes, ma'am.